All right, this is, hopefully if we finish today, this will be the very last new lesson that I teach you this year for your life, for the rest of your life. That should be enough to be happy about, right? All right, let's get right into it. I know, you haven't gotten any sleep, but that's all right. All right, here we go. I'm not going to review. I thought about reviewing briefly what we did on the other lesson, but I'm not going to. I'm just going to go right into this. You could always watch the other video if you need a little review. What's different about this compared to what we factored Friday? Did we teach? Yeah, we had class Friday, right? Yeah. So what's different about this compared to what we've done in the past? Look at the title. Factoring trinomials with a lead coefficient. Now, if you look at 5.6a, it said with a lead coefficient of 1. But this says with a lead coefficient what? Not 1. All right. What is the lead coefficient to this? 5. That's right. Okay. So this is a little different. All right. Do you have a question or you're going to answer that question? You can look up here. I see a couple. All right. So here's what we're going to do. I'm going to show you a little, I hate to say trick, but it kind of is. I actually watched some YouTube videos on this. Now, I've taught this before and I've done this thing before. But I think I was actually teaching. I would think I was a teacher the first time I learned this method. It used to be that I did this. Watch. Just guess and check. All right? Or I forget we called it something. I don't know. But this is the way I always used to teach it. And I used to think that there's got to be a better way. And then I was teaching, I think it was a college algebra class, my first year at Red Lion, I believe. And I was showing them like, oh, Mr. Jackson did this in Algebra 2 last year, and he did this method, and they showed me how to do it, right? And I was like, what? I didn't know that existed. All right, so I went to Mr. Jackson, and he showed me the method. I was like, oh, my word, that's such a way better method. So I've been teaching it that way ever since. But a lot of people would do it like this, kind of like what we were doing Friday when you had a lead coefficient of 1. Now, everything's positive, so you know that's going to be positive and that's going to be positive. Now, what has to be true about these first two? They have to multiply to be what? 5, correct? And these two have to multiply to be what? No, not 7, but 2, right? Remember that? So it's very similar to what we did on Friday when you had a lead coefficient of 1. But here's the difference. It used to be those two numbers, they multiply to be 2, and these same two numbers add up to be 7. Is that even possible in this one? Can I take, what two numbers multiply to be 2? Like integers, like whole numbers. 2 and 1, that's it, right? Is there any way to get 2 and 1 to add up to be a 7? No, there's no way in the world, okay? But what you're going to do is you're going to do this. You're going to take these two, right, the first and the last, and you're going to give me a second. Yes, you're going to multiply them together, and then when you add them up, it's going to be a 5x. All right? So, don't even write this down, because we're not going to do it this way. We're going to do a better way. I just want to show you what we used to do. And this is actually a pretty easy problem compared to some other ones. All right? But I'm going to show you a method, and it works just about every single time. So, this first one times this first one has to equal what? Not just 5, but 5x squared. So again, this is pretty easy because there's not many choices for 5. There's not many choices for 2. So what times what equals 5x squared? 5, not just 5, 5x times what? Times 1x. Good. Okay, would you agree? And what times what equals 2? 1 times 2 or 2 times 1. Now, I'm going to, let's go 1 times 2, like you said, all right? Because this actually doesn't work. I just want to show you, all right? So what you do is this. You look to this and you say, okay, what times what is that? So you put whatever you think goes there. Now, what if that was like an 8? Or what if it was like a 27? Or what if it was like a 64 or something like that, okay? You're going to have a lot of different options, wouldn't you? On 5, it's pretty easy. So this one's pretty simple. And then 2, there's hardly any options with that, all right? It's just 2 and 1, all right? So how do we know if this works? Well, we FOIL it and see if it works. 5x times x is 5x squared. So far, so good. But then look, 5x times 2 is what? No, I'm sorry. I was looking at this. You're absolutely right. It's 10x plus the inside, which is what? 1x. What's that? Is that the same as that? It's not. So does this work? No, it doesn't. So you got to try again. So you move some things around. All right. What do you think you would move around in this situation? I would move the 2 and the 1 around. So instead of 1 times 2, let's make it what? 2 times 1. Let's try that. All right. Now see if it works. 5x squared. Okay. It's the outside and inside, right, that's going to change. So what's 5x times 1? 5x plus 2x is 7x. Does that work? Yes, it does. All right. But I'm telling you, there's problems where you have to factor that you might be trying different numbers like 4, 5, 6, 7 times until you get it to work correctly. Is that efficient? Do you think that's a good way to do things? No, not at all. All right. So we need a better way. We need a better way. And we have one. I looked it up on YouTube to see how other people did it. People had different names for it. I don't have a fancy name for it. We're just going to call it the method. That's our method to factor, okay? So this is our method. Here's what we do first. Oh, by the way, there might be some problems in the homework I give you. I'm not sure because I didn't go through them and do them, and I didn't have my answer key, so I wasn't able to look. But there may be some problems where you can't even factor it. So how do you know if you can factor it or not factor it? Well, I'm glad you asked that question. Very astute of you. So there's a way to do that. I'm not going to go into like why it is and all that kind of stuff. I could talk a lot about this, but I'm just going to show you. Here's a little way to see if you can factor this. All right, and they call it the test for factorability. For factorability. All right, so here's a test to see if we can factor this thing. Because not every trinomial with x squared and x and then a number can you factor. There are some you just can't factor, all right? So let's first of all see if we can factor it to begin with. If we decide we can factor it, then we're going to go ahead and I'll show you the method. Everybody with me? So here's the test. You're going to use this little formula, b squared minus 4ac. Like where in the world does that come from? Well, it's a long story. I could show it to you. Not going to because we don't have enough time. But what you're going to do is you're going to put it into here. Must be something about that chair because Chauncey was snoring in that chair on Friday. Now he's snoring. Is it the chair? Makes you snore? I guess. I don't know. All right. So let's put the stuff in here. Now, if this comes out to an integer, all right? So if this, I hate to say this, but equals an integer. There's another way I could write this. I'm not going to worry about that right now, though. All right, if this is an integer, what does that mean, an integer? What's an integer? They're kind of like whole numbers, but you can also include what else? Negatives, okay? So if this comes out to be an integer, then this can be factored. You follow me on that? So what is the b and the a and the c? Well, this is kind of written ax squared plus bx plus c. So let's put it in here. Let's put the numbers in here. What is the b in this problem right here? It's 7. And then what are we going to do to that 7? Square it. Minus 4 times a times c. What's our a? 5. Good. And what's our c? It's right there. It's 2. Let's see what that comes out to be. Actually, you know what? I didn't read this whole thing. It's got to be a perfect square integer. My bad on that. Because I was looking at this, I'm like, wait a minute, I left something out. It has to be not just any integer, it's got to be a perfect square. Laughing because we have a student that is snoring. Probably as bad as my wife does. I sleep next to Snoring like that every single night. All right, so here we go. It's got to be a perfect square integer. Give me some perfect squares. 1's a perfect square. What's the next perfect square after that? Not 2. 2 squared, which is what? 4. 3 squared is 9, 16, 25, okay? So if this thing comes out to one of these numbers, comma, dot, 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 right? If it comes out to one of those numbers, then I can square this thing. All right, so let's do it. What is that? That's 49. What's that? 20 times 2 is what? 40. 49 minus 40 is 9. Is 9 a perfect square? Yes, it's a perfect square. So yes, I can factor it. Is that my answer? No. It's just a test to see if I can factor it or not. So there could possibly be a problem on the test where you can't factor it. So don't try to go through the whole process and factor it first and then like, oh man, I don't know what to do. I don't think it factors. Do this first, and this will tell you if it'll factor or not. Does that make sense? All right, so now we know it factors. So now let's actually factor it. Bet you're excited about this, aren't you? So what we're going to do is we're going to take these two outside numbers right there, and we're going to multiply them together. All right, let's do it right here. Well, what's that going to be? Yes? No? All right, so let's multiply those numbers together. What do we get? We get 10. We just get 10, right? 5 times 2. Yeah, we're just the coefficients, okay? Yep, the 5 and the 2 is a 10. So what we need to do is kind of like what we did Friday, right? We said, what two numbers multiply to be this, and the same two numbers add up to be this. Do you remember that? And again, I was watching some videos, and to tell you the truth, I like my little way of doing this better than anything else I saw on YouTube last night. And I watched 4 or 5 people factor stuff like this because I wanted to hear their explanations, and I thought, well, maybe there's a better explanation. To tell you the truth, I think I explain it better than any people on YouTube do. Well, I'm on YouTube, so anyway. So I like doing this. Now, they multiply to be that, but what are they going to have to add up to be? 7, the middle one, okay? So I want to find what two numbers multiply to be 10 and the same exact two numbers add up to be 7. That's pretty easy. What numbers multiply to be 10 and add up to be 7? 5 and 2, right? Would you agree? Because you only have 2 choices. You got 1 and 10, you got 5 and 2. That's it. 1 and 10 is not going to give you a 7, but 5 and 2 absolutely will give you a 7. So I'm going to use 5 and 2. So 5 times 2 is 10, and 5 plus 2 is 7. Now, what do I do with that? Well, I'm glad you asked. What we're going to do is we're going to take that middle one right there. We're going to split it up. What two things add up to be 7? The 5 and the 2. So we're going to split this up into a 5x plus a what? 2x. Okay? That's the whole reason we did this little bit right here. So this little bit right here, I'll put a little cloud over it. Okay? You could kind of do that in your head, or you could write it down on a piece of paper next to your problem, right there. So those are the numbers that we want. So what I'm going to do is write 5x squared plus, now instead of writing 7x, how am I going to write it? Plus what? I'm going to split it up. 5x plus 2x. Okay? And then I'm going to write off the rest of the equation.
Would the fine students please come to the office? Gideon Samuel, Cam Crawford, Logan Hill, Bailey Villas.
Now what we're going to do is we are going to factor this by grouping. Do you remember a few lessons ago, we did factor by grouping? So here's what we're going to do. Oh, by the way, I probably could have put 2 times 5 and 2 plus 5, agreed? But the reason I did 5 and 2, because of this. See how I have a 5 here and I got a 5 here? I wouldn't have anything in common. If I put a 2x right there, I wouldn't have anything in common with 5 and 2. So I put, I do put them in a correct order. I put this one next to this one, all right? And you'll see what we're going to do with this in a second. So what I'm going to do is this. I'm going to group them. I'm going to group those two together, and I'm going to group those two together right there. Now, let's take a look at that first grouping. What's in common? I'm going to factor out a greatest common factor. What's in common with this stuff? What is it? What did you say, 5x or just x? Yep, 5x. Okay, factor out of 5x. What do I get now once I factor out of 5x from this? So I take this and I divide it by 5x. Well, 5 divided by 5 is 1. X squared divided by x is x plus what? 5x divided by 5x is 1. We good with that? All right, let's do the same thing to the other one, and I'll show you how it works out. It's almost like magic. It's kind of exciting. So what happens here? What's in common with both of these? A 2. So I factor out a 2. What am I left with? 2x divided by 2 is x. 2 divided by 2 is 1. Check this out. Look, both of these have an x plus 1, don't they? All right, so what I'm going to do is now I'm going to factor out another greatest common factor. What's in common with this and this? The x plus 1's in common with both of them, so I'm going to factor that out. That's something that we've done before. Now, if I take an x plus 1 out of this thing, what am I left with? 5x. If I take an x plus 1 out of this thing, what am I left with? Plus 2. Does that look familiar? It does. Now, it's in a little different order. You could keep it like that. It's perfectly fine. But most of the time, if you look at an answer key, they would put the bigger one first. But it does not matter. Either one of those. But this is probably more like an answer key would give you. All right, they just put the 5x plus 2 first. And there you go. It's factored. Now you're like, Mr. Hamrick, I did that in my head way quicker than I did all that stuff. That is true. This particular problem, you might have been able to do that in your head faster than what we just did right there. But it's not always going to be that easy, okay? Those, to figure out your different factors and all that, sometimes it's just not that easy. So this is a lot more, I don't want to say accurate, but it's more streamlined, it's more regimental, it's more by the book instead of just guessing a whole bunch of stuff. Because I hate that. I hate to guess. Give me a way to do it, you know? Give me a way to do it, and that's what I'm going to do, all right? I'm not going to do this, but you could always check to make sure that it works. How can you always check to see if this is what we started with? Do the what? Give me one word. FOIL. Yeah, FOIL it. So 5x times x is 5x squared. Remember what we're trying to get? We're trying to get that. Then the outside is a 5x. The inside, the outside is 5x. The inside is 2x. That's 7x right there. Then the last, 2 times 1 is 2. Yep, it works. All right, if you just want to check it in your head, that'll be good. But see how nice that was? See how nice? Especially this step. That's my favorite step right there. Once you factor out the common factors of the grouping, then you're like, oh, this parentheses and this parentheses are the same thing, so that must mean it's in common. Pull it out, figure out what's left over. The 5x plus 2 is left over, and then boom, there it is. It's factored, and it works. So that technically was not one of your examples. It was just to kind of teach you how to do it, okay? Here is one of your examples, your official example. We're going to do a few of these, all right? And we got a good amount of time. I got, what, 20 minutes, 23 minutes? So example 4. All these say to factor. All right. They put p, 3p squared minus 4p minus 4. First of all, let's do a test to see if this thing factors. And I'm telling you that one of these examples, is it the next one? Yep, it's the next one. I'll just give you a heads up. The next one you can't factor, all right? So you don't want to go through all the steps and try to factor it and then come up to a roadblock. You want to do the test first and make sure you can factor it, all right? So what is the test? It's b squared, remember it? Minus 4ac, all right? So let's do the test. Remember, this is your a, this is your b, and this is your c. So let's put it in here, b squared. Well, it's negative 4, and I'm squaring it. That's going to be a positive 16. We'll do that in a second. Minus 4 times a times c. And you're probably thinking, where in the world did you get that b squared minus 4ac? Did you just pull it out of the blue? No, you didn't really, okay? But there's stuff that we would learn later on if we had time to show you where this comes from, okay? I'm just not going to do it today. Or ever for you guys. Anyway, ac, what is a? 3, and c is not 4, but negative 4. So let's do this. This is positive 16. This is going to be negative times a negative, which is positive. What's that? 12, right? And 4 is what? 48? Is that right? What's that? 64? Okay. Now, what do we look for on this test? We're looking at the 64. Is it a perfect square? Yeah, because 8 squared is 64. So it is a perfect square. I like to put yes. And an exclamation point because I'm so happy that it can factor, okay? All right, so it can factor. So now I'm good. I'm good with going ahead and doing this. But what if it didn't come out to a perfect square? Then I would just say it can't be factored. So don't even bother going through the steps to factor it because it can't be factored. This one can, so we're going to bother, all right? What do we do first? Take the last two numbers, the two n numbers right there, the 3 and the negative 4, we're going to multiply them together. What does it multiply together to be? Negative 12. So we need to find two numbers that multiply to be negative 12, and those same two numbers have to add up to be what? Not negative 12, but what? Negative 4, the one in the middle, okay, that middle coefficient. You could, I watched a video, and this lady, she wrote down all the possible variations of what times what is 12. But I think we can do this in our head. All right, let's just go through a couple of these in our head. What times what is 12? Well, 1 times 12. Is there any way I can get a negative 4 out of that when I add them? A 1 and a 12? Nah. What's the next one? 2 and what? 6. What about, 2 and 6? I might be able to get that. What do you think? Yeah, because 2 times 6 is 12, but I do have different signs in here, all right? I got negatives in here. So what do you think? What adds up to be negative 4? Using 6 and 2, some combination of negative and positive, which ones add up to be negative 4? Negative 6 and positive 2. Very good. All right? So negative 6 plus 2 is negative 4, and negative 6 times positive 2 is negative 12. So those are my two numbers. What am I using those numbers for? I'm using those numbers because I want to take this number right there and break it up. Actually, I could circle the whole thing. I want to take that and break it up into negative 6p plus 2p. Everybody see that? That's why I did this. All right, so let's do it. Let's write 3p squared. Let's go negative 6p plus 2p minus 4. Now I'm going to group them. I'm going to go a little faster than I did the first one because I'm not explaining every little thing. There is something in common with both of these. So there's a 3 in common with both of these. So I factor out a 3 and a p. What am I left with when I factor that out? 3p squared divided by 3p is p minus 6 divided by 3 is 2. P divided by p is 1, so it's just p minus 2. Plus, what's in common with this? Greatest common factor. There's a 2 in common. So I factor out a 2, and I'm left with p minus 2. Now check it out. Both of these are the same. If one comes out different than the other, you did something wrong. In fact, last night on a problem, I didn't do it correctly because, stupid me, I wrote down the number wrong. That wasn't, I think it might have been this one. I put a 16 instead of a 6 or something stupid like that, right? It wasn't even a math error. It was just, I just took a number and I made it 16 instead of a 6. So that was dumb. But I realized that I did something wrong because these two parentheses came out to be different things, right? So they got to be the same. Now, what's true? What can I do with both of these? I can factor out this common factor of p minus 2. So factor out p minus 2. What am I left with then? 3p plus 2, and that's your answer. If you wanted to, most likely they'll probably write it like this, 3p plus 2 times p minus 2. It's the same exact thing. I would circle that, and then that's your answer right there. You kind of following now? Yeah? All right. Let's do another one. Well, what did I say about this next one? I already gave you a heads up on this, didn't I? Right, it can't be factored. So let's see why it can't be factored. So here we go. 4x squared minus 3x minus 5. I mean, at first glance, you look at that, it looks just like the problems we've already done today, doesn't it? It looks very similar to what we just did on the last one. But you're not going to know it can't factor unless you do the test. So let's do the test. what does the test say? Well, let's put it b squared minus 4ac to the test. All right? This is our a, this is our b, and this is our c. So let's put it in. B squared. That's negative 3 squared minus 4 times a, which is a positive 4, times c, which is a negative 5. Let's see what we get. That's a 9. That's going to be a plus. And that's 4 times 5 is 20. 20 times 4 is 80. All right. And what do we get? 89. Is that one of our perfect squares? No, it's not. All right. There's nothing times itself that equals 89. So does it pass the test? No, it does not pass the test. So it cannot be factored. If you want, I would be perfectly fine by you saying this. Cannot be factored. This is what the book says, though. They use the word prime. You know how a prime number is only one in itself? Well, it's kind of like this. Okay, what multiplies together to be this? Well, just one in itself. Okay, you can't break it down into anything else. All right, that's why they say prime. So that's the answer that you'll see. If you do an odd problem and it's a prime, then that's what you write. That was nice. I wish all of them were prime, don't you? Nah, that wouldn't be fun because we wouldn't be able to factor anything. All right, let's do another one. This may possibly be it. Nah, there's a couple at the end. I am going to skip a couple. All right, and I didn't give you any homework with the ones that I skipped, so don't worry about it. About me skipping them. It's just because I know time is of the essence here, so that's why I decided to skip them. All right, we're going to factor. Now this looks a little different, but we're going to do a little bit of rearranging. Okay, so that looks not really like what we've been doing. First of all, it's got two variables. The other ones only had one variable, right? What's the first thing you should always do when you see a factor problem, though? You should always look to see if you can do what to it. Give me the word. Greatest common factor. Very good. Okay, so let's do that first. Let's see if there's anything in common with all three of those. Because those other problems that we did, there was nothing in common with all three of them, all right? But on this one, there is. Yeah, 2, right? Because you got 6, 10, and 24. 2 is the only thing that goes into those, right? There's nothing bigger because of that 10, all right? And then what else? A y. So let's factor out a 2y. Let's find out what we have now. So if I take this and divide it by 2y, I just get a 12. Put a plus. Take this and divide it by 2y. 10 divided by 2 is 5. That y cancels out. I'm left with the x. Put a minus. 6 divided by 2 is 3. And then that y cancels, and I'm left with 3x squared. Let's do something else. Because I want to rearrange this. I'll tell you what. You could have done this a couple ways, but watch. I'll do it this way. Let's rearrange this so it's in descending order. So what's going to go first? The x squared, right? So what's it going to be? Minus 3x squared. What's next? Plus 5x, and then plus 12. There's still an issue with this. Before I even begin to look for my trinomial factoring, I'm going to have to do something. I don't like what about this. What about this bothers me inside the parentheses? What is it? The negative. Very good. That negative. Everybody see it? Okay, all three of you that are still watching, literally all three. All right, so I got to get rid of that negative. What do? Let's factor it out, okay? So I'm going to basically divide everything by -1, all right? I'm going to take that negative and put it out here. So that's going to give me a negative 2y. But now watch very carefully. If I divided everything by a negative, what does this become? A positive 3x squared. What does this become? A minus 5x, and this one, minus 12. There we go. We haven't even started factoring the trinomial yet. Okay, all we did was try to get it into a way, into a look that we're used to. All right, so I've got a positive, I've got an x squared, got an x, got a number. These minuses, I'm fine with that. We already did an equation where we had two minuses in there. No big deal. Don't forget to always include that negative 2y, though. Don't just throw it away. So I always keep that negative 2y out in front. Now, what I'm going to do is this. I take this number and this number. What do I do to those? Multiply them together, and I get negative 36. All right? So remember the little rule, the little trick? These two numbers multiply, or what two numbers multiply to be negative 36, and those same exact two numbers have to add up to be what? Not negative 36, but the middle one. What's the middle one? It's negative 5. So let's think of 36. Well, 1 times 36, no way. 2 times 18, no way. 3 goes into it. 3 times what? 12, but there's no way I can get a 5 out of that, is there? What's the next one? 4, right? 4 times what? 4 times 7 is 36? 4 times what, Olivia? Is 36. 4 times... Go ahead, say it. Do you know it? No? We don't know 4 times what? 9, thank you. Somebody knows their multiplication tables. Man, that's a lost art. This is why it's important to know your multiplication tables. It really is. Okay, anyway, enough of that. So 4 times 9. Is there any way I can get a 4 and a 9 to become a 5 or a negative 5? Yeah, if one's negative, right? And I need it negative because they multiply to be negative, so one's got to be positive, one's got to be negative. Which one's going to be the negative, the 9 or the 5? The 9. So this is going to be negative 9 plus what? I said 5 earlier. I meant 4. Negative 9 plus 4. So negative 9 plus 4 is negative 5. Negative 9 times 4 is what? Negative 36. Those are my numbers. Those are my numbers that I'm going to take this and split it up into that. All right? So here we go. I write 3x squared. Am I going to put a 4x first or a 9x first? Because look, it's next to this 3x squared. Do I want to put a 4 here? No, because they won't have anything in common. So which one am I going to put in front? The 9. So it's a negative 9x plus a 4x and then minus 12. See, all I did was just turn that negative 5x into negative 9x plus 4x. That's all I did. You see that? Now what I can do is group. Yes, question. Yeah, when you didn't have a coefficient of 1, absolutely. But we just did this. We put 2 parentheses and we said these two numbers have to multiply to the same, I'm sorry. Yeah. Now you got me. Okay, put an x here and an x here. They have to multiply. You got to find two numbers that multiply to be whatever this is, and then these two numbers multiply to be your last term, and these two numbers added together add up to be your middle term. That's what I'm trying to say, all right? That's when you had a coefficient of 1. So yeah, there's definitely similarities to this. Definitely similarities. That part right there, that's your thing that's similar to what we did earlier on Friday, okay? All right, let's do this. Let's break this up like that, okay? And then what do we get here? We got a 3, and then we're going to factor out, oh, not just a 3, but what? 3x. So factor out a 3x. What are we left with? 3x squared divided by 3x is x, minus 9x divided by 3x is 3, plus, let's factor out what from this? Not just a 2, but what else? A 4. 4 is the greatest common factor. So factor out a 4. What are we left with? X minus 3. And look, these two things in parentheses are the same. That's an indication that you're doing this right. Okay? Keep that minus 2 out there. Keep a big old parentheses. Now, let's factor. The x minus 3 is in common with this term, and it's in common with this term. So let's factor it out. So I'm going to factor out x minus 3. What's left? What if I take an x minus 3 out of this whole thing? What am I left with? A 3x. What if I factor out an x minus 3 from this? What am I left with? plus 4. And that is your answer right there. Now it's completely factored. Bless you. The book writes it like, actually, yeah, I think the book probably writes it like this, but it doesn't make any difference. They just flip-flop the 3x plus 4 and the x minus 3. And there you go. So that way is perfectly fine. This way is perfectly fine, but this way is probably, if you were going to look in the book, it'll probably write it like this, but you don't have to write it like this. You can keep it like this. You look at the book looks like this. You're like, yep, that's the same thing. I'm good to go. No reason to change it. Just keep it like that. So that's basically yeah, we could do another one. I'm just running out of time. Let me see. I'm going to stop. You guys have been so good today. Just by showing up. I appreciate it. Even if you did sleep in my class, at least you showed up. So that's half the battle, right? Didn't I have a little talk on that the other day? Yeah. Do those little talks make any difference at all in your life? Do you ever think about them at all? Yes, no, maybe. Do you? Okay. I know, you guys been up all night. I was up till 1 o'clock. I was watching you guys. So anyway, I said, do any of those so-called inspirational talks do any good, or is it just a waste of time? Should I just keep teaching math and not even try? That's my question. All right, that's enough of that. So I'm going to write this down in case anybody that wasn't here today didn't remember, but we talked about it last week, and it's recorded because I remember in class saying, I'm saying this. The test is on Thursday. Oh, I have lesson plans for you too. That's May 9th. And it's chapter 5. And we are going to review Tuesday and Wednesday. All right, we're going to take the test on Thursday, and of course you do the corrections on Friday. If you don't show, if you are a no-show, and you have no note for me, you don't have an email from a parent, you don't have an email from a doctor or a written note or anything like that, if you just do not show up on Thursday, all right, guess what's going to happen? If no show on May 9th, what's going to happen? Yes, I'm going to give you a 0. Now, I said earlier I was going to give you a 50%. I changed my mind, okay? I have full rights to do this, okay? Every teacher in the world would agree with me on this. If you don't show up for this test, all right, and you just refuse to take it, you will get a 0%. Remember, this is the only test we take this marking period. The only one. We had one quiz and a whole bunch of homeworks, all right? They'll count, obviously, but a 0 would be devastating. It would be devastating to your grade. I don't think you could recover. I really don't. I don't think that you could pass this marking period with a 0 on the test. All right? Now, I'm preaching to the choir because 1, 2, 3, 4, 5, 6 people are here out of 26. So I'm talking to the 20 that may possibly be watching this on YouTube. If you don't show up on Thursday, May 9th, to take this test, you will get a 0%, not a 50. I said 50 the other day. I changed my mind. All right? I have the right to change my mind. I will give you a 0%. I won't give it to you. You will have earned it. Would you agree? I'm not giving you a 0. You earned a 0% because you didn't show up. All right? Everybody good? The senioritis has just gone way overboard. Just way, way overboard. And I'm putting a stop to it, at least in my class. All right? I'm standing up against it. All right. That wasn't a very positive ending for a last lesson of the year, was it? But I'm going to be putting the reviews online anyway, so I still have more talking to do. So we'll try to be a little more positive at the end of the last one. Everybody good? All right.